Welcome to Second Take, the show that focuses on the issues behind the news. The construction of the first dish antennas for what will become the biggest scientific instrument in South African history is underway. The instrument will be the MeerKAT radio telescope, which will consist of up to 80 dishes. With me in the studio today is Engineering News Senior Contributing Editor Keith Campbell, who will unpack the details of the project. Keith, what is radio astronomy and what exactly is an array?
Well, radio astronomy is looking at the heavens, looking at our universe in radio waves. A lot of phenomenon objects in our galaxy and the wider universe emit radio waves. Phenomena such as quasars, which are believed to be supermassive black holes in the center of galaxies, incredibly long distance away from us, or pulsars, which are rapidly rotating neutron stars which emit pulses of radio waves at incredibly regular intervals. So regular that when they were first discovered, the astronomers who discovered them for a period seriously considered that they could be signs of alien civilization. You can perhaps think of optical astronomy, traditional astronomy with telescopes, as looking at the universe, and you can think of radio astronomy as listening to the universe. The data is, however, usually processed into images, not pictures, images. Radio astronomy and optical astronomy are not the only forms of astronomy. There's also gamma ray astronomy, X-ray astronomy, and infrared astronomy. But infrared, gamma, and X-ray astronomy cannot be done from the surface of the planet Earth. They have to be done either in the high atmosphere or from space telescopes. Now, an array is where several radio telescopes are linked together to look at the same object at the same time. This technique has developed over the past few decades. It is known as interferometry. It originally involved a situation in which several radio telescopes would look at an object at the same time and would record the data. And then the tapes of the data would be sent to a central point, and they'd have to be played together and coordinated to get the combined data picture from the telescopes. An observation might take 2 or 3 hours. Processing the data could take 2 or 3 or more months. More recently, radio telescopes that are close together have been linked by microwave towers, but the amount of data that microwave can transmit is very limited. Most recently of all, we now have radio telescopes linked by optical fibers, which can transmit virtually all the data in real time. So the data is coming in all at once. There is no need to spend months coordinating it. It accelerates the analysis dramatically. Now, this advance in communications technology has made it possible to develop the concept of large-scale arrays, in which you have many radio telescopes looking at the same object at the same time. The thing with an array is it creates a virtual telescope that is much, much bigger than not only the individual telescopes together, but the individual telescopes combined, if you were simply to take their surface areas and the theoretical reception capability of the combined surface areas.
Keith, can you explain what the MeerKAT is?
Well, the MeerKAT is going to be one of these arrays. It's going to involve, as you said, up to 80 dishes, which will look at the same object at the same time. They'll be linked by optical fibers, and they'll create the effect of a gigantic telescope, allowing us to resolve much, much greater detail of these different phenomenon objects. The MeerKAT is going to be preceded by a prototype known as KAT-7. KAT for Karoo Array Telescope, 7 because it involves 7 dishes. This is being built at this moment and hopefully will come into operation sometime next year.
What South African technology is used in MeerKAT specifically?
Well, a number of South African technologies are being developed for MeerKAT and also for possible use in the International Square Kilometre Array, which will be an absolutely gigantic array telescope which is scheduled to be situated either in South Africa in the Karoo or in Australia. The decision will be taken in a couple of years. Now, the most obvious for the general public piece of South African technology will be the dishes themselves, which are being manufactured out of composites. This is the first time that radio telescope dishes are being manufactured from composites. Traditionally, they're made out of metal. There is a prototype dish which has been erected at the Hartebeesthoek Radio Astronomy Observatory west of Pretoria. That prototype is 15 meters in diameter. The Cat 7 and MeerKAT dishes will be 12 meters in diameter. If this works, if they provide the necessary performance, it will greatly reduce the cost of MeerKAT and of the SKA in comparison with the use of traditional metal dishes. The South Africans have also been involved in the development of advanced computing algorithms and of other software for the operation of the telescopes and their coordination, and are also developing advanced radio feeds, again with the intent to maximize performance and minimize cost, and also in certain computing hardware which allows extremely rapid parallel computing.
Now it comes to one of the main questions that I think a lot of people are thinking about. Will we be able to contact aliens by using the MeerKAT?
Actively contact them if they exist? No. Listen for them? Yes. The MeerKAT would allow us to listen for signs of alien civilization, provided they're transmitting on radio frequencies. Indeed, what is officially called the Search for Extraterrestrial Intelligence, or SETI, is one of the reasons for the construction of the Square Kilometre Array. South Africa hopes to host the Square Kilometre Array, which should cost about €1.5 billion. And if it does, then MeerKAT would become precursor of the SKA and would be incorporated into the SKA. If SKA is built in Australia, MeerKAT will remain operational here as a very major radio telescope instrument indeed.
Sounds very exciting. Thank you so much for your time, Keith. That's the show for today. Join us again next time for more analysis and insight into some of the major science and economic stories making headlines.